Welcome to the Electrical and Electronic Engineering Lecture Series. Your anchor person is Professor Michael Ndinechi. Our topic today is Model 031, Flowchart Design Process. Please follow me in this lecture series by subscribing to my YouTube channel at https://youtube.com/@Ndinechi Please like, share, and drop your comments in the comment section or reach out to me using my email addresses. I would like you to listen to my lectures on general purpose computers, Module 014 Part 5, at the link provided. Then another one is my lectures on computer software types on Module 014 Part 4, and my lectures on the design process and flowcharting on Module 029. All can be seen using the link provided. Now, flowcharting. An important tool for writing a program is the flowchart. If you are a programmer, you must learn how to prepare a very good flowchart. With that, you will know when you are deviating from your set out design. So we say flowcharting enables the programmer to plan the sequence of operations in a program before writing it. Flowcharting, therefore, is a convenient way of expressing on paper in diagrammatic form the activities involved in attaining a required sequence in which the activities must be performed. Flowchart serves three useful purposes. One, it helps to work out how a problem can be best solved. Two, as a means of illustrating a proposed system for management consideration. And three, as a permanent record of procedures and activities. An example of flowchart of the entire program procedure, which we developed in our previous lecture, which is Module 029, we will use as an illustration in Fig 1. But before we get to Fig 1, we must know or learn how to prepare flowcharts. When constructing a flowchart, four basic factors must be looked into. One, you must have an objective in mind. Any programming act must start with an objective in mind. The flowchart will now be the process of working out how these objectives can be achieved. Two, there must be a starting point. And this starting point is the circumstance that triggers off the activities or the series of activities necessary to achieve the objective. Three, there must be the activities itself. And the activity is that are necessary and the sequence in which these operations must be performed. If the circumstances will always be the same, it will just be a case of putting them in a logical sequence, A to B to C, and so on. But this is not always the case, since some circumstances tend to vary within a situation, thereby giving rise to the need for alternative activities. For example, instead of processing from A to B, it may be from A to B or to C, in which case B and C are alternatives, depending on certain circumstances. In flow charting, we are concerned with taking into account all of these circumstances that could arise and defining all the activities that these give rise to. 4, there must be decisions. So this is the process of deciding which alternative activities that must be performed in order to reach the aim when faced with differing circumstances. Like we said before, can be from A to B or C. So there are 2 circumstances. So you must take a decision, which one to follow. With these 4 factors in mind, it is suggested that the following approach be taken in flowchart construction. A, you make a note of the aim of the chart. B, you must decide at what point the series of activities are going to start. C, you must make a note in logical order of the main activities that are likely to be involved. And D, you must start with the first activity and decide what different actions this could give rise to. And E, you have to trace these actions arising out of a decision, one at a time, going as far as possible with one before going back to the other alternative. Therefore, a flowchart is made up of a set of symbols, the shapes of which indicate the nature of the operations being described, supplemented by connection lines and arrows that show the flow of control between the various symbols. Basically, 2 types of flowcharts exist. The first one is called the system flowchart. So this emphasizes data flow among machines and does not emphasize how the data has to be converted to obtain the desired result. Therefore, the second one is the program flow chart. So this indicates the logical sequence of events transforming the input to the desired output. The symbols for flowcharting are as shown below. It is important that you know the symbols of flowchart. In some circumstances, we see people just draw something and call it flowchart. If you are not using these symbols that are dedicated to flowchart, what you have is not a flowchart. It will be a flow diagram. But if you call it a flowchart, you must follow and use the standard symbols for flowchart. So the first one there is called the terminal symbol, which shows starting or stopping point in a program. The small circle is called the connector symbol, which shows the exit to or entry from another part of the chart. And the trapezium there, which is the input or output symbol used for reading and sending data. For instance, if you want to get data from the source or you want to output data, this is the symbol you use. Then you have the next one, which is, a rectangle. It's called the process symbol. So any processing function or operation causing change in form, value, or location of information, you use that. For instance, you want to tell your program, in the program, you want to tell your computer to perform a process. Something like do 2 times 4 is a process. You are not getting the 2, you are not getting the 4. The data is already there, and you are just doing a process, 2 times 4. So you use that symbol, which is a rectangle. Then you have this symbol, which is called diamond symbol, with 1 arrow pointing in and 2 arrows pointing out. That's, anytime you see that, it's called a decision symbol. I say this is a decision or switching type operation that determines which of the alternative paths to follow. The 2 outgoing arrows will usually bear yes or no. Remember, we are dealing with digital systems which makes use of zeros and ones. Yes or no, true or false. So one of the outgoing arrow must be when the decision is yes, and the other when the decision is no. It is carelessness if you make this symbol to have 4 terminals. Then what you have done is not a flow chart. It must be 1 arrow going in and 2 arrows going out. Of course, we have the arrow lines which show operation sequence and data flow directions. Then we have this other side, which is a rectangle with 2 lines inside, and it's called a predefined process. That is, 1 or more named operations or program steps specified in subroutine or another set of flowchart. In our previous lecture, we have looked at what is a subroutine. Then you have a small circle with a cross inside. It's called the summation symbol. Of course, we have this symbol like a banner. It's called the off-page connector symbol. Then you have this symbol called the terminal symbol, displays terminal. Then direct access storage. That is, these symbols are necessary if you want to go ahead to specify the type of input or output that your system you want to use in your program. For instance, if you want to give manual input, you see the figure there like trapezium. Then circle with cross inside is where you want to do all operation. When we get to do our logic technique, we will see, or Boolean algebra, we will see the OR operations. So when you want to do the OR operation, that is the symbol you use. And of course, if you are using magnetic disk, you stored data. In fact, These signs, if you are using Microsoft Word, if you go to the menu bar and click on shapes, it will give you all the flowchart symbols. There, you can learn more about that using your word processor. So now, if you are preparing a flowchart, you must know the type of design you want to do. Are you doing a modular design, top-down design, or bottom-up design? So it is very important that you talk about the method you are going to apply in your design. So we say three main design approaches are available to programmers and systems analysts. These are modular approach, top-down design approach, bottom-up design approach. So if we look at the modular design approach, we say that this is the method whereby one tries to break the problem to be solved, or the problem you want to program to solve, in models, and try to find solution to each stage before combining the different stages into a united whole. This method reduces the complexity of the design since it is handled piecemeal, that is, one after the other, before combining them finally. This process also makes debugging process very easy. In our previous lectures, we have talked about debugging. We've mentioned some debugging software. So we expect you know what debugging is all about. So we have the top-down design, which is sometimes called structured design approach. So by the top-down design or structured design approach of a program, we mean the following method. One, you define the problem that the program is meant to solve. Then you write plain language statements of an algorithm for solving the problem. When you do this, we call it the top level of the design. Remember the name top-down design approach. So this is the top level of the design. Then two, you write the algorithm as a sequence of procedures that are going to be used. In our previous lecture, we also defined what an algorithm is. Now, you write the procedures in structured language and include any needed control structures. You call this the level one, down from the top of the design. Then three, you refine the procedures in step two into simpler procedures. You continue to refine until each procedure is translated into the simplest step-by-step instructions. So as you continue to do this, you see that there will be many levels of this refinement. So you say there are as many of these successive refinements as necessary. There are your step three, and you get to step four, and that is the structured language, that is step-by-step instructions at the end of step three differ from programming language or codes only in syntactical details. Then you go to coding. So the next will be coding the structured algorithm in an appropriate programming language. And this completes the top-down design structured approach. We call this the bottom level of the design. So The next one is the bottom up. Well, in bottom up, it's assumed you already know the answer, so you work from the answer to now get to the problem that has that answer. This may not be very easy when you are doing your design, but in some cases, you already know the answer. You now walk back to get the problem. So you say the bottom up, this is the method of program development whereby the programmer starts from the unknown to the known. That is, starting from the solution and then working up to the problem. Now, in our previous lecture, we looked at the 8 steps involved in design process. We call them problem identification, algorithm development, flowcharts or pseudocode development, code program in high language, converts, and all those things. Now, if you look at this flowchart, which we call Fig 1, we say that it's flowchart for program development procedure. So if you look at our beginning point to the left, we say start. Like we defined, you must start your program and you use that symbol. That symbol which is, an ellipse, some cases an ellipse. That is the closest thing to describe that start symbol. So now we are talking of drawing a flow chart for program development. So like we said, the first thing you do is to identify the problem. So identifying the problem, you are not getting input, it's a process. So we use the rectangle, which is a process symbol. Then we go down. The next thing we do is step-by-step algorithm development, which is also a process. So we use the rectangle, which is a process symbol. Then we go down, prepare the flowchart and pseudocode for the program, which is also a process. We use rectangle. We go down, say, code the program in any high-level language, is a process. We convert the program to machine form, is a process. You compile the program, which is also a process. Now, after compiling the program, you now take a decision. Are you seeing any compilation error? You see the line move up again to enter the decision box. Now, if you look at the decision box, you see 1 arrow coming in and 2 arrows going out. You take a decision. Any compilation error, if there is compilation error, what do? You go back to code again. So you say, any compilation error, yes. You see the arrow or the line going to go back to where you recode your program in any high-level language and continue to come back to the decision box. Now, assuming you now compile and there is no compilation error, when you ask, it will say no. Then, if there is no compilation error, what do? You execute the program with your test data. After that, you take a decision again. Did it give you correct result? If the answer is no, then something is wrong. You have to debug that program. After debugging that program, you can see you go back and start again step by step to continue to go down. If at the first decision your answer is yes, you go back. If it is no, you come back. If you now execute with test data again and it is correct now, your answer becomes yes. Then you go down to execute the program with actual data. After executing the program with actual data, what do? You check whether the result is accepted by the final user. If the result is not accepted by the final user, no, it means that what you develop is not solving the problem the user wants. You will go back to first identify again the problem the user wants you to solve, because the meaning is that you've not been able to identify the problem correctly. If you check the result and it's acceptable by the user, then your work is done. You stop. So you can see that the start and the stop button are the same. So let's quickly look at this example to see how much we understood what you are saying. So example 1, a company gives 10% commission to each sales agent if their monthly sales amount to 5 million naira or more. The question says, draw a flow chart to calculate the commission given to sales agents. So what you do is to start the program, you initialize the commission to be 0. It's a process. So you use the rectangular sign for process, symbol for process. Then you go down, you get the sales amount. You can see you are using the parallelogram symbol because you are getting, it's an input. You are getting it from an input device. So get sales amount X. Then you take a decision. Is this sales amount equal to or greater than 5 million? From our question, if it is equal to 5 million or more, the agent gets 10%. So if the amount is 5 million or more, equal to or greater than 5 million naira, yes, then you compute the commission, which is a process. Commission equals X, that is the amount you got from the input, multiplied by 10%, which is 0.10. Then you display the commission. But if you take that decision and the amount is not up to 5 million naira, then your answer becomes no. So you go down to display commission, and the commission you display, that display commission, you can see that it is a parallelogram, which means it is an output. You display it in your, maybe your graphical user interface to see commission. And because there is no commission given, that initial commission equals 0. You stated at the input, you stated at the beginning of the program, will be displayed, and the program ends. So, you see, with that, you'll be able to, write the code now that can, perform this. If you subscribe to my channel, by the time we will do small programming, like, very simple one, using either basic or Fortran or C, we'll be able to, write now this flowchart we are saying, to code it in a program that can run in our computers. So example 2, modify example 1 to show when the company decides to pay 2% if the amount is less than 5 million naira. The first one is you must get 5 million or more to get commission. But we are saying here, we want to modify that so that you get 2% if your sales is not up to 5 million or more. So we start again, you initialize commission. Commission equals to 0. You get the sales amount X. Now, you ask that question again. Is this sales amount X equal to or greater than 5 million naira? If your answer is yes, you compute commission equals X times 0.1, that is 10%. If it is no, you now say commission equals X times 0.02, that is 2%. And you display the commission in your graphical user interface and stop the program. Again, we can have example 3. Say this time around, we want to draw a flowchart to get a number and test if it is an odd number. Odd number. You continue to get numbers and test until an odd number is encountered. Then your program stops. So, like before, we start. We get any number. You can see we are using that parallelogram showing we are getting something from an input. It could be from the keyboard. So get any number, you call that number Z. Now, how do you know an odd number? Say any number you divide with 2 and has a remainder is an odd number. Now, simple mathematics. So now you receive the number from the input device. You divide that number by 2 and set remainder equals X. If you divide the number by 2 and set the remainder to be equal to X, now you test that Z, that X. Is X equal to 0? You see question mark. If the answer is yes, it means that that number is not an odd number. You go back and get another number. You divide it by 2, say the remainder equal to X. If the remainder is 0, you check your decision box. Is X equal 0? Yes. You go back, get another number. But if X equals 0 and says no, automatically it means that there is a remainder, which is 1. Then you display the number. You can see the parallelogram sign showing output. Say display Z. I put in brackets and put that equal odd number in purple. The special reason for doing that is when you are writing a program, anything you put in quote will appear like that. The system is not going to see it as instruction. It will just reproduce it like that. So if, for instance, we've gotten the input, we get a number Z, and that number Z is 25, for instance. We divide it by 2 and say the remainder to be equal to X. That remainder will be 1. So when you get to the decision box and ask, is X equal to 0? The answer will tell you no. Then you display that Z, that number. Now, what you will see at the output will be 25 equals odd number. That is what you will see on your screen, because you put equals odd number in quotes when you write your program and put anything in quotes. The system produces it like that. So the answer, what we see in our screen, will be 25 equal odd number, and the program will end, because our question says you continue to test until you get an odd number, meaning immediately you get the number Z and it is odd number, then the program ends. So I will want you, say, revision assignment, show how you can do a flowchart to find the average of 7 numbers. Let's see how you can, do that. So draw a flowchart to find the average of 7 scores. You're 7 in a class, you did a test. The teacher is expected to give the average score of the 7 students. You can easily draw a flowchart that can do that. So do that and put in the comment section. Let's see how far you understood what we are saying. But I would like you to know that you must follow standard symbols. And we say standard symbols are there in the Microsoft Word. If you click on, shapes, it will open and show you the flowchart symbols. So you must use them and draw your flowchart to be as clean as possible. When you do that, it will be in your way of preparing what people will like. And if you are a presenter, as you use it to present to your management, you will see your work will be appreciated. Thank you for listening. But before you go, there's something I want you to know. You can call it words of wisdom. It says, opportunities are time conscious. Opportunities are time conscious. If you waste your time, the train carrying opportunities, will pass. Therefore, be time conscious to meet your opportunity. Please share this lecture with your friends, your colleagues. Next time, by this time tomorrow, we will be live again, and we'll be talking about some safety tips in the laboratories, because many of us get to the laboratories as students without knowing what to do. For now, we are looking at electrical and electronic engineering laboratories. What you must do because of accidental, happenings in electrical and electronic engineering laboratory. So tomorrow by 8 o'clock, it will be just a 15-20 minutes lecture on safety tips in the lab. Thank you.